Hello, we are here to talk about 4.9 El Nino and La Nina. So let's get it going. First question, do you remember this map that I had shown you previously? What we're looking at here are the major gyres of the world, showing surface currents in the ocean. Each gyre is comprised of a few different ocean surface currents. This particular map is showing, 3 or 4 currents per gyre. That's not important, but what's important is seeing in the Pacific Ocean the equatorial currents in the Pacific Ocean. Those equatorial currents, as you can see in both the South Pacific and in the North Pacific, they are moving from the eastern portion of the Pacific Ocean to the western portion of the Pacific Ocean. And that is something important to take note of. The currents are moving from east to west, and the reason why they're moving from east to west is due to the Coriolis effect and due to the way which is based on how the planet is spinning. And it's important to note that you've got warm water being pushed from the eastern Pacific towards the western Pacific. Okay, so just kind of keep that in the back of your mind. Next, looking more at some basic things here. Next, we're going to talk about another type of current that's important in the world of El Nino. And that current is called an upwelling current. An upwelling current is not a type of surface current. So it's not like these currents here, but rather it's a deep water current called a subsurface, sub meaning beneath. And so what these upwelling currents do, they move water or mix water from the bottom of the ocean towards the surface, moving it up. It's bringing colder water, because there's colder water at the bottom of the ocean. Colder water that's also got a lot of nutrients from the depths up to the surface. Why is there a lot of nutrients in the water in the deep ocean? Because dead things are sinking, and once they reach the bottom of the ocean, those dead things are decomposing, and the process of decomposition releases nutrients. So there's a lot of nutrients in the bottom of the ocean. These upwelling currents, which occur in various locations around the planet, these upwelling currents bring those nutrients from the bottom of the ocean to the top, as you can see in the diagram on my screen. These upwelling currents and the regions surrounding them are super duper important to the ocean food web, because the nutrients that are brought to the surface are used by organisms at the surface. They're used by phytoplankton, which are the base of the food web in the ocean. Phytoplankton are plant plankton, little microscopic algae. And they are the whole bottom of the food chain in the ocean. They are responsible for taking nutrients and carbon dioxide and sunlight and converting that into glucose. And then everything else feeds off of that glucose. Phytoplankton feed zooplankton, little animal plankton, which are eating the phytoplankton. Small fishes eat the zooplankton. Medium-sized fishes eat the small fishes, and yada, yada, yada. So this upwelling current is really important in terms of bringing nutrients to the surface. And by bringing nutrients to the surface, it affects the whole food web. Okay? So again, just giving you some basics here. This is just a diagram showing an area of upwelling off the California coast. If you've ever been to the Farallon Islands, there's a national park there. There's a big area of upwelling. There's other areas of upwelling off the coast of Ecuador and Peru, and that'll come into play when we talk about El Nino. All right, so first, again, just kind of like giving you background here. We're we're going to talk about what's happening under normal conditions. I don't like this diagram. Let's use this one. Okay, so this diagram here, what you're looking at is kind of a couple of different things. The upper portion of the diagram, you're looking at a map. You've got Central America, South America. Over on the left side, you've got part of Australia. And then in the middle, you've got the Pacific Ocean. And then the lower portion is a profile of the ocean, going from the surface downward. So this is what things look like under normal, non-El Nino, non-La Nina conditions. Under normal conditions, there is warm water moving across the surface of the Pacific Ocean. Why is there warm water moving across the surface of the Pacific Ocean? Because of the way the winds are blowing. Think back to that first map I showed you. So warm water is traveling from the eastern Pacific across towards the western Pacific. And as it's traveling across the equator, it's receiving a lot of sunlight, therefore it's getting very warm. So we end up with a lot of warm water over here in the western Pacific, and we call that the warm pool. And because we have a lot of warm water over here in the western Pacific, you also get a lot of evaporation. Because you have a lot of evaporation, that water vapor will eventually cool and condense and come down as rain. So you do get, an okay amount of rainfall over here in the western Pacific. Because you've got a lot of warm water means more evaporation, which means more condensation and precipitation. So that's ocean currents under normal conditions on the surface. In the atmosphere, under normal non-El Nino conditions, winds are blowing from east to west, and that's totally normal. In this area of the world, in the equatorial Pacific, winds are blowing from east to west. Okay, just talking normal conditions. And then looking deep into the ocean, you have something called a thermocline. That is an area of change. Like when we're talking oceanography, something that ends in the suffix cline, C-L-I-N-E, it means an area of rapid change. So the thermocline is an area where temperature changes rapidly. So the thermocline is kind of a mixing zone between warm water and cold water. And you can see here the thermocline under normal conditions goes all the way to the surface. It allows cold water way over here in the eastern Pacific. It allows that cold water to get up to the surface. That's our upwelling current. So under normal conditions, upwelling occurs in the eastern Pacific Ocean off the coast of South America. The upwelling current and the cold water can rise up to the surface. All those nutrients help the phytoplankton, which in turn help everything else. So that's kind of the beginning of our story. Just giving you basics, a little foundation to build on. I'm actually going to stop this video here because I am limited to 15 minutes for each of my videos. And so I will stop at this point and start a new one when I start talking El Nino. So to kind of sum up, we were talking about normal conditions. Normally, winds are blowing from the eastern Pacific to the western Pacific. Therefore, ocean currents are moving from the eastern Pacific to the western Pacific, carrying all that warm water over to the western Pacific. So there's a lot of evaporation and precipitation. And then also under the surface of the ocean, you've got a cold upwelling current coming to the surface over near South America. All right, so that's our normal conditions, and we'll start talking El Nino in the next video. So ta-ta for now.